This is gonna blow your mind. The James Webb Space Telescope is set to uncover the universe's deepest secrets. For centuries, we humans have gazed at the stars. We have yearned to understand our place within this cosmic ocean. We built telescopes, each one better than the last. The Hubble Space Telescope showed us wonders. It pulled back a curtain on distant galaxies and vibrant nebulae, but we wanted to see more. We needed to see farther. We needed to see the very beginning. So, we dreamed bigger. We conceived of a new eye on the cosmos, an observatory of unprecedented power. This dream became the James Webb Space Telescope, or JWST. Its mission was simple yet profound: to look back in time, to witness the dawn of the first stars and galaxies. What makes the James Webb Space Telescope so special? Imagine a mirror, not just any mirror, a colossal mirror over 6 meters across, segmented into 18 golden hexagons. This marvel collects light, faint ancient light that has traveled for billions of years, light from the universe's infancy. But JWST doesn't just see visible light like Hubble. Its true power lies in the infrared. Why infrared? Because the universe is expanding. As light from distant objects travels towards us, it gets stretched. Its wavelength increases, shifting it towards the red end of the spectrum. For the most ancient objects, this light is stretched all the way into the infrared. JWST is built to capture these elusive photons. To perform its extraordinary task, JWST needs to be cold, extremely cold. Any heat from the telescope itself would blind its sensitive instruments. So, engineers designed a magnificent sunshield, 5 layers thin as a human hair, spread out to the size of a tennis court. This shield blocks the light and heat from the sun, earth, and moon. It allows the telescope to cool down to a frigid -233 degrees Celsius. JWST doesn't orbit Earth like Hubble. Instead, it resides much farther out, at a special point in space called the Second Lagrange Point, or L2, about 1.5 million kilometers away, a true sentinel in the dark, perfectly poised to observe the universe. The scientific community waited for JWST with bated breath. Decades of planning, years of construction and testing, billions of dollars invested, the hopes of a generation of astronomers rested on its shoulders. It promised to revolutionize astrophysics, to answer questions we hadn't even thought to ask. It was more than just a machine. It was a human endeavor of the highest order, a testament to our curiosity, our relentless desire to explore, to understand. The telescope launched. It unfolded flawlessly in space. It began to send back its first images, and the universe as we knew it was about to change forever. What wonders, or perhaps what terrors, awaited our gaze? Dr. Helen Krauss was a brilliant astrophysicist. She had dedicated her life to studying the most distant objects in the universe, the faintest flickers from the cosmic dawn. She was one of the principal investigators using the James Webb Space Telescope. Her current target was GNZ 11, a galaxy so far away its light had traveled for over 13.4 billion years to reach us. It was one of the oldest and most distant galaxies ever observed. Dr. Krauss was using JWST's unparalleled power to study its properties, to understand how the first galaxies formed. It was supposed to be a routine observation, another piece in the grand cosmic puzzle, but the universe had other plans. The data began to stream into the control center. Dr. Krauss watched intently as the images resolved on her screen. She expected to see the familiar faint smudge of GNZ 11, but something was wrong, terribly wrong. Near the galaxy, yet distinctly separate from it, was a distortion, a bizarre localized disturbance in the fabric of space-time itself. It wasn't an instrument artifact, all systems were nominal. It wasn't a known celestial object. It looked like a tear, a rip in the very canvas of the cosmos. Dr. Krauss felt a chill run down her spine. This was impossible. This was something new, something profoundly unsettling. The anomaly was unlike anything ever seen before. It wasn't a black hole devouring everything around it. It wasn't a gravitational lens, bending light in predictable ways. This was different. It appeared as a region of intense, localized warping. Light seemed to behave erratically near its edges. Some wavelengths were absorbed, others were strangely refracted. It was as if a small patch of the universe had its physical laws abruptly rewritten. Dr. Krauss stared at the telemetry, her mind racing. This wasn't just a glitch in the data. This was a glitch in the universe. A profound sense of unease settled over her. The cosmos was not behaving as expected. Dr. Krauss and her team immediately went into overdrive. They recalibrated instruments, they ran diagnostic checks, they cross-referenced data from other telescopes, though none had the power to see what JWST was seeing with such clarity. Every mundane explanation was meticulously ruled out. The anomaly was real, it was persistent, the data was undeniable. The James Webb Space Telescope, in its quest to see the beginning of the universe, had stumbled upon something that challenged its very foundations. Dr. Krauss knew she had to report this. The implications were too vast. The universe was showing humanity a secret it wasn't prepared for. The full arsenal of scientific analysis was brought to bear on these cosmic tears. Spectrographs dissected the light, or lack thereof, coming from and around them. Gravitational lensing models were applied, but they failed to explain the precise nature of the distortions. The tears weren't simply bending space-time like massive objects do. They seemed to be discontinuities, actual breaks or punctures in the cosmic fabric. Scientists wondered if these were gateways to other universes, or perhaps regions where space-time itself had decayed. The initial data was baffling. Each new observation only deepened the mystery, posing more questions than answers. These were not black holes. Black holes have event horizons and singularities with well-understood gravitational effects. The tears had different spectral signatures. They didn't accrete matter in the same way. They weren't wormholes as depicted in science fiction, connecting distant points in space. These were more like wounds, raw, open sores on the face of the universe. They seemed to absorb certain frequencies of light entirely, while others passed through, oddly twisted. Some tears even exhibited faint, almost imperceptible emissions, a strange energy signature that defied classification. The physics required to describe such phenomena simply did not exist in our current textbooks. The characteristics of the tears were perplexing. They appeared to be incredibly stable, yet they also showed subtle fluctuations. Some scientists described it as a kind of shimmering at their edges, as if the boundary between our space-time and whatever lay beyond was not entirely fixed. The light absorption was selective, almost as if the tears had a preference. This specificity was particularly troubling because natural phenomena usually exhibit broader, more predictable behaviors. The edges of these tears were also remarkably sharp, too well defined for naturally occurring cosmic structures which tend to be diffuse or chaotic. This suggested an unnatural origin. Existing cosmological models began to crack under the strain of this new data. Dark matter and dark energy were already profound mysteries, placeholders for our ignorance about the universe's composition and fate. But the tears were an order of magnitude stranger. They didn't fit into any established framework. They hinted at a universe far more complex and perhaps far more fragile than we had ever imagined. The very laws of physics, once thought to be universal, now seemed to have exceptions. Or perhaps there were new laws waiting to be discovered, hidden within these enigmatic cosmic wounds. The quest for understanding became more urgent than ever. A universe on alert. Emergency meetings and global collaboration. Dr. Helen Krauss presented her verified findings to a select committee of leading astrophysicists and space agency officials. The atmosphere in the room was thick with tension. As she detailed the observations of the cosmic tears near GNZ 11, a stunned silence fell. Then came the deluge of questions. Skepticism quickly gave way to a dawning realization of the discovery's magnitude. This wasn't just an astronomical curiosity, it was a potential paradigm shift in our understanding of reality itself. The implications stretched far beyond the realm of science, touching upon philosophy, security, and the very future of humanity. The burden of this knowledge was immense. An emergency summit was convened in absolute secrecy. The world's top cosmologists, particle physicists, mathematicians, and heads of major space programs were summoned. They gathered in a secluded location, away from the prying eyes of the media and the public. The agenda was singular: to understand the nature of these cosmic tears and to decide how to proceed. The weight of the unknown pressed down on everyone present. Were these natural phenomena? Were they signs of an incredibly advanced extraterrestrial civilization? Or were they something far more alien, far more fundamental? The discussions were intense, running day and night. Fear mingled with a profound sense of awe. It quickly became clear that this challenge was too great for any single nation or institution. The cosmic tears were a global concern, potentially a universal one. A landmark decision was made to foster unprecedented international collaboration. Data from JWST and other observatories would be shared openly, though securely, among a trusted consortium of researchers. Resources would be pooled. A global task force codenamed Project Riftwatch was established. Telescopes around the world and in orbit were retasked to search for more tears, to monitor the known ones, and to gather every possible scrap of information. Humanity, for a moment, stood united against a cosmic enigma. However, alongside the push for understanding, there was an equally strong imperative to control the information. The potential for public panic, misinformation, and societal disruption was enormous. How could one explain to the world that the universe itself seemed to be damaged, or perhaps deliberately altered? The initial decision was to maintain strict secrecy. Findings needed to be triple-checked, theories explored, and a coherent, understandable narrative prepared before any public disclosure. This period of secrecy was fraught with ethical dilemmas, balancing the public's right to know against the perceived need to prevent chaos. The truth in this case was a heavy burden. Whispers of design: the enigmatic geometric patterns. The dedicated search by Project Riftwatch yielded more results. More tears were discovered. They weren't confined to the vicinity of GNZ11. These strange rifts appeared in other ancient, distant regions of the observable universe. They were scattered, yet their distribution was not random. As more data points accumulated, a disturbing pattern began to emerge. The tears seemed to be located at specific points, forming a network or a constellation of anomalies. This was a chilling development. Randomness is a hallmark of many natural processes on cosmic scales. Order, especially complex order, often implies something else, something more deliberate. The geometry was subtle at first, then undeniable. The tears aligned along vast, unseen axes. The distances between them, when calculated across billions of light-years, seemed to follow mathematical progressions. Certain angles recurred with statistical significance. It was as if someone, or something, had meticulously placed these ruptures in space-time. The patterns were too precise, too consistent to be attributed to chance or to any known natural phenomenon like galaxy clustering or large-scale structure formation. This discovery sent a new wave of shock through the scientific community. The implications were staggering, pointing towards something beyond comprehension. The most unsettling implication was, of course, intelligent design. If the tears were not natural, then they had to be artificial. But what kind of intelligence could operate on such a scale? What technology could manipulate the fabric of space-time itself, creating stable rifts across cosmic distances? The patterns hinted at a purpose. Was it a communication system, a transportation network, a cosmic engineering project of unimaginable scope? Or perhaps something far more ominous, like a weapon system or a prison? The scientists involved found themselves grappling with questions that had long been the domain of philosophers and science fiction writers. The possibility of an advanced extraterrestrial civilization, perhaps a Kardashev Type 3 civilization capable of harnessing the energy of an entire galaxy, was discussed. Or could it be evidence of something even more advanced, something beyond the Kardashev scale entirely? The geometric precision suggested a level of understanding of the universe that dwarfed humanity's own. The universe suddenly felt less empty, but also potentially more dangerous. The silence of the cosmos, which we had long interpreted as solitude, might instead have been the quiet before a revelation we were not prepared for. The patterns in the void whispered of an intelligence, ancient and vast. A world in awe and fear, public reaction and information control. Despite the best efforts to maintain secrecy, the news of the cosmic tears eventually began to leak. Perhaps it was an insider with a conscience or a slip-up in secure communications. Soon, sensational headlines blazed across news outlets worldwide. Rips in reality, Webb telescope finds holes in space, scientists baffled by cosmic anomalies. The initial reports were fragmented, often inaccurate, but they ignited a firestorm of public interest. The world, already grappling with terrestrial challenges, now had to confront a mystery of cosmic proportions. The genie was out of the bottle, and there was no putting it back. The public was hungry for answers. The global reaction was a complex tapestry of emotions. There was immense awe at the power of the James Webb Space Telescope and the sheer scale of the discovery. Many felt a renewed sense of wonder about the universe, a thrill at the prospect of such a profound mystery. However, alongside this excitement, there was also widespread fear and anxiety. The idea of tears in space-time sounded terrifying. It tapped into primal fears of the unknown, of cosmic fragility. Existential questions bubbled to the surface. What did this mean for humanity's place in the universe? Was our reality stable? Were we safe? Philosophical and religious debates intensified overnight. The media, in its relentless pursuit of engagement, often amplified the most sensational aspects. Scientists like Dr. Krauss were thrust into the spotlight, hounded for explanations they were still struggling to formulate. Speculation ran rampant. Conspiracy theories blossomed across the internet. It was a government cover-up of alien contact. It was a sign of the apocalypse. It was a hoax. The line between credible scientific inquiry and wild conjecture became increasingly blurred in the public discourse. Every new image from JWST, every scientific paper was scrutinized and often misinterpreted, fueling both fascination and fear in equal measure. Governments and scientific institutions found themselves in a difficult position. They scrambled to manage the flow of information, to provide accurate updates without causing mass hysteria. Numerous press conferences were held. Educational materials were quickly developed and disseminated. But the sheer mind-bending nature of the discovery made it difficult to communicate effectively. How do you explain a potential geometric pattern in space-time anomalies to a public accustomed to more concrete realities? Trust in official sources was tested. Some accused authorities of hiding the full truth, while others criticized them for alarming the populace. It was a communications nightmare. Beyond the horizon, reshaping our cosmic perspective. The discovery of the cosmic tears and the enigmatic patterns they formed has irrevocably reshaped our understanding of the universe. Fundamental concepts that underpinned cosmology for decades are now being questioned. The Big Bang Theory, the nature of space-time, the accelerating expansion driven by dark energy, all these models must now accommodate these new, unexpected phenomena. The tears are not just anomalies, they are signposts pointing towards a new, deeper level of physics, one that might unify gravity with quantum mechanics or reveal entirely new forces and dimensions. The rulebook of the cosmos is being rewritten before our very eyes. The search for answers has become the most pressing endeavor in modern science. New theoretical frameworks are being proposed daily, ranging from modifications to general relativity to exotic string theory constructs and ideas about a multiverse. Observational campaigns have been intensified. Scientists are desperately seeking more tears, analyzing their properties with even greater precision, and trying to decipher the meaning behind their geometric arrangement. Is this a natural, albeit bizarre, feature of our universe that we are only now capable of detecting? Or is it, as the pattern suggests, the handiwork of an intelligence so advanced it defies our current comprehension? Humanity's perception of its place in the cosmos has undergone a profound shift. For so long we have pondered our solitude, gazing out at a seemingly empty universe. The discovery of the tears, especially if their patterns imply design, shatters that sense of cosmic loneliness. It replaces it with something far more complex, The possibility that we are not alone, but that our cosmic neighbors operate on scales and with motives that are utterly alien to us. We are no longer just inhabitants of a random planet, we are potentially observers or even subjects in a structured, perhaps engineered universe. This realization is both exhilarating and terrifying. The James Webb Space Telescope was built to peer back at the first light of creation. It has done that, and so much more. It has opened a door to a mystery that will likely occupy scientists and thinkers for generations to come. It serves as a powerful reminder that the universe is far stranger and more wonderful than we can possibly imagine. Our quest for knowledge, our innate human drive to explore and understand, will continue. The cosmic tears are not an endpoint, but a new beginning. A startling invitation to push the boundaries of our understanding further than ever before. The adventure into the great unknown has just taken an unexpected and truly cosmic turn.